Alright guys, so here are my notes about factoring by GCF. We're going to use the greatest common factor today, just like we talked about last notes, to factor a polynomial. So this is going to be sort of new. Before we get into it though, I'm going to show you guys really where this is coming from. We're going to do sort of the reverse of something that we already know how to do. We're going to do the reverse of the distributive property. So what should probably help here is if we practice the distributive property again. So that's why I have a couple different problems about the distributive property on here. We can scroll down here and do a couple of them together if you guys want. Maybe I'll do like 1 and 2. I'll pause the video and then you guys can try some of them if you'd like. So on number 1, really the only thing you need to watch out for is that -6 going to the a to make -6a, and the -6 to the 8 to make -48. So again, what I'm going to do today is I'm going to give you something that looks like this, and you're going to go back to the original question. And we've already talked about why we're doing this. That's going to help us solve equations with this eventually. But yeah, like I said, if we're good at this, if we're good at distributing, the opposite shouldn't be so bad. So let's take a look at number 2 as well. On number 2, going to distribute that 4 out to the 1 to make 4, and distribute the 4 out to the 9x to make positive 36x. So would you guys pause the video for a second, try these ones down here, and then unpause and we can check our answers together. Alright, so I actually did all the problems for you, so you can just check your answers. Really the only ones that I want to talk about are maybe number 6 and number 5. On number 5, the really big thing you got to watch out for are those two negatives. So the -8 to the -4 makes a positive 32, and the same thing with the positive 24. Maybe on number 4, that could have been a little bit confusing because the 2 is in the back. Remember the 2 just goes to the 8m, or 9m to make 18, and 2 can go to 10 to make 20. One thing I do want to talk about though, and maybe we can take a look at number 7 again, is the box method. I don't know if you guys remember the whole box method thing. That is when we would make a little box. In this case, it was 1 by 2, and we would put the 5 on the outside and the 1 minus 7n on the inside, and then our answer would be inside of the box. It would be like one of those Punnett squares. So you would go 5 times 1 to get 5, and then 5 times -7n to get -35 n's. And I said, you probably don't need that for distributing like this, but we really used it a lot when we were distributing binomials. So we're really going to focus on this today because this is going to make factoring a lot easier. So if we switch to the next page, you guys will see what I mean. So on this one, we're going to factor this. So here's the final answer that I would have gotten. What I'm going to ask for you guys to do is give me what the problem would have been. So that being said, we're going to use one of the skills that we learned yesterday, finding the GCF of numbers. So let's find the GCF of this guy. So what is the GCF? What's the biggest thing that can be taken out of 3 and 3, and then a squared and a? Well, obviously you can take a 3 out, right? A 3 belongs to both of those. And how about the a's? So we talked about it as in like boyfriends or girlfriends or something like that. So if this one has 2 and this one has 1, how many could they have in common? Well, the most they could have in common is 1. So 3a is my GCF. So now, what would have to go on top? What would have been on top in order to make 3a squared? What more would you need to multiply 3a by to get 3a squared? Just an a. And what more would you need to multiply 3a by to get 3a? Well, nothing, right? So in that case, you're just going to put a 1, because you still need to multiply it by something to make it. So your problem would have been 3a, parentheses, a plus 1. And if you want to check it, you could. And the way you would check it is just distribute it out. 3a times a is 3a squared, like we said, and 3a times 1 is plus 3a. Let's try this one down here now. So again, I'm going to put my box around the 2 questions, or around the 2 factors. And I'm going to see what is the biggest thing that, or what is the GCF of these 2 things. What can I take out of 5 and 10? Well, obviously a 5. And then how about the A's and B's and all that stuff? Well, just 1a, and that's it, I think. So what would have to go on top in order to make 10? 2? And how about the a and the b? Well, because there's already an a right there, you just need a b. And same thing as the one up above, this one's just going to be a plus 1. All right? So your final answer for this one would have been 5a, parentheses, 2b plus 1. All right, so why don't you guys pause the video, try 1 and 2, and we'll take a look at it together here in a second. All right, hopefully that was enough time for you guys to pause it. We're going to scroll down here and take a look at 1 and 2. So I'm going to put the box around it. Biggest thing I can pull out of 6 and 18 is 6. And can I take any y's out? Nope. So what more do you need to put up here in order to make 6y squared? Obviously the y squared. And what would you need to put up here in order to make the 18? The plus 3. So your factored form of this is going to be 6 times y squared plus 3. And again, you could always distribute it out to check. 6 times y squared is 6y squared. And 6 times 3 is plus 18. So again, this is your answer. Let's take a look at number 2. This one should have been a little bit trickier. What is the GCF of those guys? Well, between the 27 and the 18, it is 9. How about the Y's? Again, this one has had 3 girlfriends. This one has had 2. What's the most they could have had in common? Obviously, it's 2. So, what would have to go on top in order to make 27? Well, obviously, if 3. How about with the Y's, though? How many more Y's do you need to make in order to make 3? Well, you already have 2, so you just need 1 more. And how about on top of this guy? Obviously, it plus 2. And you already have your 2 y's, so you're all set. So your final answer for this one would have been 9y squared, parentheses, 3y plus 2. All right, let's take a look at the next page, guys. So again, this is basically going to be the same thing. There's just a couple more examples just to make sure that we're confident with it. So let's take a look at one that has 3 terms. It says factor 12x squared plus 21x, or 12x to the third plus 21x squared plus 15x. First thing we need to do is find the GCF of all 3 of those. So when we were doing our IXL on this, I actually thought it was easier with 3 because it sort of narrows it down a little bit. What's the biggest thing that can divide 12, 21, and 15? What are the only things that can divide 15? 3 and 5, right? Can 3 or 5 divide either 21 or 12? Obviously it's a 3, so our GCF is going to be a 3. How about with your x's? This one has had 3 girlfriends, this one has had 2, this one has had 1. What's the most they all could have had in common? Obviously just 1. So 3x is my GCF. So that's nice. So that's going to be the thing outside the parentheses. So I'm even going to prep my answer by putting the 3x out here. So now when I do my box method, and I have my 3x out here, all I need to do now is figure out what would go on top. So what's going to go on top in order to make 12? 4. And how many more x's do I need? 2. And then what's going to go on top to make 21? Obviously a 7. And how many more x's? 1 more. And what's going to go on top to make 15? Obviously a 5. And do I need any more x's? Nope, I'm all done. So that's my answer. 4x squared plus 7x plus 5. So it's really not that much harder when you have 3 terms. So why don't we go down here? I have a couple different problems for us to try. Down here on 1, 2, and 3. So would you guys pause the video and try them for me, and then unpause to check. All right, so let's do these real quick. What's the biggest thing you can pull out of 20x squared and 15x? It's going to be a 5x. And after you make your box, pull out 5x. What goes on top to make 20? Obviously, it's going to be a 4. And what's going to make the x squared? Another x. And what's going to make the negative 15x? Negative 3. So your final answer is going to be 5x times 4x minus 3. Let's take a look at number 2. What's the biggest thing that you can take out of 44a squared and 11a? It's going to be 11 and a. So after I make my box, what more in order to make 44? 4. How many more a's? 1. 1. 4a plus 1. And then on number 3, we're going to multiply both of those by, or divide, we can divide both of those by 12, I think. And can I pull out any letters? No, they don't have anything in common there. So 12, parentheses, what are you going to have to multiply 12 by to make 24? 2, and a y. And then 12 to make negative 36x was going to be negative 3x. So 12 times 2y minus 3x. We're going to skip that other part of this paper, and we're going to go on to the back here. On the back, it says factor out the greatest common factor using this. So we're going to just do a couple more examples here, and then we're done. So let's take a look at this guy. What's the biggest thing I can pull out of 2, 4, and 10? Believe it's a 2. And how about x's? X. So let's make our box, and let's figure out what needs to go on top. To make negative 2x to the third, I already have a positive 2, so I need a negative 1. And what else? How many x's? Hopefully you're thinking 2. And in order to make the 4x squared, obviously I already have 2, so I need to go plus 2x. And in order to make the negative 10x, obviously I need a minus 5. So your final answer is 2x, parentheses, negative 1x squared plus 2x minus 5. And the last one that we're going to do together is example 4. There's a lot going on there, so hopefully you don't see one like this on IXL, but you might. My box around it right away. Sort of tough. What is the biggest thing that I can pull out of 3, 9, and 12? It should be pretty easy for us by now. We've done a bunch. 3. How about the G's and H's? Well, they all do share an H, so that's good. Let's pull that out. And then let's figure out what else we need. I think we're all done because G's, the 12H doesn't have a G. So on top of this one, I already have a 3. I already have an H. I just need those 3 G's. So put a G to the third up there. For this middle one, I need a negative 9, so I need a minus 3. I already have an H, but I still need those 2 G's. And the last one, how do I make a plus 12 if I already have a 3? Obviously a plus 4, and I already have an H, so I'm all set. So my final answer is 3H, parentheses, G to the third minus 3G squared plus 4. All right, last one. Try it. Pause the video. Unpause it when you're done, and then we are done. All right, hopefully that was enough time. What do you guys think for the GCF? What's the biggest number for all these? 6. How about X's or Y's? Let's say 3 Y's. All right. You need a 2 in order to make 12. Obviously, 6 times 2 is 12. You need 2 X's. And because you already have 3 Y's, you're all set. For this next one, 6 times what is 18? Obviously, plus 3. You need an X, and how many Y's do you need? Obviously 1. And for the last one, 6 times what is 36? Plus 6. You already have 3 Y's, so you need 2 more. So your final answer is 6. Y to the third, parentheses, 2x squared plus 3xy plus 6y squared. Whew, that was a lot. All right, guys, that is it. Thank you so much for watching.